Hello guys, what we're going to be working today is on our 4.3 notes, and it's over the Ferris wheel problem. Alright, what I recommend that you do is actually read it, pause the video, read it, and start the video again. Now that you have read this problem, a few things are very important. I will go ahead and highlight a few things, such as the diameter is 212 feet. It takes 80 seconds for Ferris wheel to make a full revolution. Now the car loads 8 feet from the ground, and the last one, it takes 50 seconds to reach the top. Now let's go ahead and work this problem. The first question is, how high is the top of the Texas star? In order for me to solve it, I will go ahead and make a quick and simple picture. This is the 8 feet above the ground. The diameter, meaning this whole thing, is apparently 212, and it takes 82 seconds for the Ferris wheel to make one revolution. So from the lowest point to the highest point, it should take me half of the revolution, which is 41. But this specific problem says it took 50 seconds. So if the wheel is going this way and it's taking 50 seconds, it means that it's somewhere back here. So apparently it's moving down, going this way. How high is the top of the Texas star? I would say 212 plus the 8 feet. And if you add those, you get 220. Of course, it's in feet. What time will your stopwatch read when you get back down to the bottom? If it took you 50 up all the way up here, it would be 50 plus half of the revolution, meaning 41. And your answer is 91 seconds. The last question or the next question says, how much time would it take to reach the top of the Texas star for the second time? Well, it took you 50 for the first time, plus 41 to get on the bottom. Add another 41, meaning 91 plus another 41, and you should get 132 seconds. Next question asks us to draw the sinusoidal graph of this situation. I will start by graphing my lines, knowing that this is my y-axis, this is my x-axis. I will label my y-axis and x-axis first. This axis represents the distance, and that distance is in feet. And this one represents the time, and the time is here in seconds. Well, one thing I know is it loads 8 feet above the ground. Beside the highest point, according to our first question that we solved, is 220 feet above. Halfway in between is at 114. Another thing that we know is 50 seconds after we were at the highest point. After that, it was 91 seconds after we were at the lowest point. And we went back to the highest point for the second time after 132 seconds. From here, I can graph something looking like this. All right, let's go ahead and move on to the next question. The next question says, write the equation of this situation. Well, I will start by saying D is equal to. After D is equal to, the first shift that we had there was up and down, and it was 114. Plus, our amplitude is the distance between 114 and the highest point being 212, and that's 106. And I put a plus because I'm using the cosine starting up. Inside a parenthesis, I will have t minus 50 because I'm starting 50 above. Now, to find b, I will say b is equal to 2 pi over the period. The period is between, going back to the graph, the period here is between 50 and 132. Between 50 and 132, that would be 82. So I will say over 82. So my period here is, my b is pi over 41. I will go ahead and plug this on my calculator to answer the rest. So on my calculator, on the y equal, I will put the whole equation. And once you put the whole equation, you will go to your table. Under your table, mine is already set up so that I get 15 at first. So you go to table set and set it up. For 15, apparently is 19.006 feet. For 75, you do the same thing. I can just go to table set and request for 75 and press enter and go back to the table. It should start at 75 and my answer is 78.170. So I will say 78.170 feet. You do the same thing for 5 minutes, knowing that 5 minutes is the same thing as 300 seconds, and you should get 215.060 feet. Alright, the next question says, how high were you when you started the stopwatch? When you started it was at t equals 0. Once again, you can just look at the calculator and your answer should be 32.222 feet. And was it going up or down? We discussed this already and we noted that it was moving down from the beginning. The last two questions are very interesting. What is the value of t the second time you are 100 feet off the ground? Note that we say the second time. Now on my calculator, on the y equal, on the y2, I will put 100 because that's where I'm trying to reach. And I will fix my window so that, well, I fixed my window already so that I will get better values. I will see the whole graph. I changed y max and x max to 200 and x min, I can keep it as -10. That'll be fine. And now we graph it. This is what I see. Note that I wasn't trying to see the max and the min. My goal is to see the intersection with the 100 line. So let's try to figure out what this point is. I will do second trace 5 and I'll press enter. My goal is to get close to my solution, which is this point. Enter, enter, and the answer is 72.228. So here I will put 72.22 by 9 seconds. For the second one, this one I put y2 is equal to 100. On the last one I put y2 equal 175. If you follow the same process, you should end up with 201.502 seconds.